Sabrina Fenska,
I'm Andrew Miller.
and our project is Life Beyond Earth.
Was it turned off? On the side, there's a turn on and off button in there. Oh, did you remove the, yeah, you can't, yeah, that's why we need to put, or you can just do that, yeah.
Okay, so the Copernican principle is a physics principle that states that if a theory is based on the fact that something is special or unique, then it can't be plausible. This a lot of times applies to the search for life in space. Because of the fact that life here on Earth is composed of elements that are abundant in the universe, it is not entirely plausible that we are alone, and also the fact that most sorry.
That's okay.
Anyway, sorry, I'm like really nervous right now.
Don't worry. We're just ants. We're just really little ants. Don't be so nervous. Don't think of us as humans.
Okay, so the fact that life on Earth here is composed of elements that are really abundant in the universe, and also the fact that there are probably more planets in the universe than there are words that have been spoken by humans since the beginning of time, basically, leads us to believe that we are not alone in the universe. And that is the basis of our project, is like about life on other planets. So most searches for life have centered around Earth-like planets, because we assume that life needs water, and it needs an atmosphere, and it needs things that we have on Earth, and we assume that life is if it's going to exist, it is going to look similar to the life that we have on Earth. However, we're finding many species that don't really conform to what we thought was possible. For instance, I know in California, I'm not sure, this was a couple years ago, they found a bacteria that lived in very, very high levels of arsenic, and at first I thought it was completely different to our DNA. Later on we found it wasn't, but the fact that it existed in a place where we thought life couldn't exist shows that we can find life in places that are not similar to Earth. I know there is a creature that can live within the vacuum of space. It can't like reproduce or really evolve that way, but it can survive. So that's what we're kind of basing our project on. And the aim of our project is to develop a simulation that can determine the ways in which life can exist in other environments. Of course, we can only use what we know about our biology and biology here on Earth in order to develop this simulation, but it can possibly help in the future to know what planets we can look at in order to find life that may not be similar to those here on Earth.
Alright, so where the planet is in space, it can affect how life could be brought up. Like depending on the exact location, how far it is from a star can change the temperature drastically. The gravity of the planet might not be the same as Earth's. And the UV radiation can disrupt the life living there. I'm drawing a blank.
It's okay.
Oh, the elements. Like the Earth and very common planets around us or the ones that we've found, the common elements are hydrogen, helium, carbon, and oxygen. Distant planets, they might not have the same ones. So life may be affected by these other elements. And using a simulator would be easier to map out how a planet would look.
And basically, it would make exploration easier, and it could possibly use in conjunction with like virtual realities and such, that we could make planet exploration easier in the fact that you don't necessarily have to leave Earth in order to explore a planet if we know enough about it. So this is an example of what a simulation could look like. This is basically like a wireframe simulation where you could see mountains and rocks, and preferably we would have textures on it and stuff so that you could see the composition of the soil or the rocks. And here's another example with water. And so this project is going to determine how life can evolve in different conditions. And so it's going to build off our previous knowledge of biology here on Earth in order to determine what can exist like beyond Earth.
So many companies, like such as NASA and SpaceX, should be working on something like this. So it wouldn't be common for them to use this simulation. But other companies, such as video game developers, would also use this simulation to make more realistic planets in their games. Like our game that recently came out, No Man's Sky, has many planets, a whole array of planets that, depending on where it is in the solar system, it's a different composition of what can be on there.
And also, schools can use this, students learning about, different planets, and stuff, they can use the simulation in order to learn more.
All right, so let's go into the questions. Questions?
What kind of computer setup would you need to run a simulation like this?
Didn't really go into that setup yet, but
Okay.
So would you be generating new planets or taking planets that are already
We would be looking at planets that NASA has found and being able to look at them more closely because of the things that we can know about them from just from what they found.
So basically the texture you are using in your program is already pictured, or you have to draw that out?
I'm sorry?
The texture in your application is used, how do you get it? Is by drawing or the pictures too?
Well, I guess it would depend on the texture, how it would be simulated. We haven't really gone that far into the conception. We're still working out how it would actually work and how to get the basic simulation. Hopefully we would be able to get textures, but be further down the line.
Are both of you computer cyber gamers?
Yeah.
Okay, so, and you've got Dr. Akbas, right? So Dr. Akbas should be able to probably give you some inputs as you go. So I think that's the most important aspect that you have to now put together is the questions of what programs exactly are you gonna use in the process. Because you can have very good concepts of this and that, but if there's no program available to actually do the concept, then you're going to be very limited on how you're going to implement it. So at the end of the semester, we expect that you will be able to come up with a module, or you're going to come up with the game itself. Start out. What do you think can you accomplish within the 2 months period left? Just trying to come up with a design and
come up
all
with
the
a
programs at least.
Design and maybe a demo or
Okay.
something of basic demo.
Okay, all right, that's good. Any other questions? None? All right, we're good. Thank you very much.